My name is Max. I am currently one of the tech leads for the developer platforms and experience team at LinkedIn. The brief career history is I once was the chief architect of the Bugzilla project, and then I was the technical lead for code health at Google. I was the primary author and maintainer of Google's code review guidelines, which I open sourced and you can find by searching for Google engineering practices. I'm also the author of a book called Code Simplicity and another book called Understanding Software. And also, as Justin so kindly mentioned, recently published a set of documents called the LinkedIn Developer Productivity and Happiness Framework that talks about how to use and understand data and how to implement data for your developer team. So, a common problem that teams have is they gather a bunch of data and they put it into beautiful dashboards and then nothing happens. Like what? So you got all this data, like what do you actually do with it? Not every company has a background of being data-driven. And engineering teams in particular usually don't have a background of being data-driven about their own engineering practices. They might have a background of being data-driven with their product, where the product manager is very engaged with their customers, but internally, engineers don't, go through school and go through a career where they get taught how to understand and use data. So what do you do with it? Well, at first you just have data. So this is a graph of a metric called commit success rate at LinkedIn. It tells you the percentage of times that the continuous integration, the CI system passes after merge. What do I do with that number? I don't know. It goes up sometimes, it goes down sometimes, and it makes a line on a graph. That's what it does. So almost nobody does anything with this number. But it's a number on a graph. People have it. So what do you actually need? I'm going to talk about the principles, then I'm going to talk about a specific example. For all data work, you have to know who the audience is. Who is going to look at the data, and who's going to do what with it? Basically, the question is, who is going to do what? But that breaks down into, you have to have an audience. They have to care. They have to want to do something about it, right? And then they have to actually be willing to take action on it. They can't just be sitting there giving you lip service, being like, yes, yes, I would like to have data. Who are you going to assign to do work on it? Nobody? Oh, okay. I'm not going to deliver data to you then. Why would I deliver data to you? And then action actually has to occur. There has to be some process, some rhythm of business. Something has to happen to make data happen. If you are a provider of data to other people, there are a few questions you can ask them in advance when they ask you to provide them data. These aren't the only ways to do this, but you can say, what do you think the data will say before I give it to you? What do you think it will say? And sometimes they already know. They think it will say blah. And I said, what if it doesn't say that? And they say, will that change your mind in any way? Like, will you do anything different? And if they say no, then why am I delivering them data? I'm not going to deliver them data because that's work. It's a lot of work to deliver them data and to do it right. So I'm not going to do that work if it's not going to do anything. So let's talk through a very concrete example of a project that I was the tech lead of for the last year or so, year and a half. And there's actually a bunch of different metrics that were involved in this project, but I'm going to focus on one just so that I can tell the whole story. So about a year and a half ago, an engineer in my team made a dashboard. And that dashboard just said, it was actually an experiment. He wanted to try out using Grafana. And so he said, well, I'll do it with this data. And it was just like this basic page. Like you can basically see the whole dashboard there, except for that I've redacted all the numbers. Because they're bad numbers, and I don't want to, share all those really bad numbers. But he said, how many of our code repos build? So at LinkedIn, there's this thing called a multi-product. The simple version of that is a multi-product is a repository. You don't have to get into the complexities of it. One multi-product, one GitHub repo. Okay. So this dashboard showed a terrible number. Like that bad percentage is very bad. A shockingly low percentage of our repositories actually built successfully at head. So this showed a big problem. And then we shared this data with a bunch of our other senior engineers just to sort of like stoke the fire. right? That was the first thing we did. Like, it helps us sometimes create a little outrage. Show the smoke, right? Be like, yeah, people like, yeah, there's some fire there. And then those people, not me, bubble that up to management. And are like, look at this nonsense. We should get the developer productivity team to do something about that. That's me. I mean, I'm not the whole team, right? But like, you know what I mean. That's us. However, even with all that, action only really started once there was some broader strategic initiative that the company cared about that this data aligned with. So in the case of LinkedIn, that was migrations. The problem that LinkedIn was facing was a lot of either in progress or needed to be done large-scale code migrations. And LinkedIn has hundreds of millions of lines of code. So when you want to make a change, it takes a long time and it's very complicated. And so the thought was we need to build better automation for doing migrations. However, myself and others pointed out that that will be impossible in the current state of the world. And the reason is we don't know who the owners of our code bases are. Many of our code bases don't build at head, so you don't know if the changes are safe or not because the build was already failing. The dependencies, and I'm not going to explain all of LinkedIn's dependency ecosystem, but it's very, very complicated. The dependencies of our repositories were extremely far out of date, sometimes over a year or 2 years out of date. And there's also a lot of migrations that actually require you to fully roll out everything to production, like to remove all the old code that's in production so that it stops doing the old bad thing. And a lot of our binaries were old, very old in production. And so we proposed 4 metrics to track and to run and to actually solve the problem. And it's these 4 that are listed on those things. So we ran all these. I'm just going to talk about green builds because it's one concrete example. Now, a lot of the time people think, oh, you know what? We need to have a metric. The first thing we should do is we should make a dashboard so we can show management. That's not the first thing you should do. You have a few steps to do when you're going to actually start on a data journey where you're going to actually take action on that data. And it's before a dashboard, okay? So the first thing, and I'm going to explain it by going through the specific example here. So let me talk a little bit about LinkedIn's dependency ecosystem that I said I wasn't going to have to talk about, but I am going to talk about a little bit about it. It has versions. It has versions. You can depend on versions of repositories with semantic versioning, okay? So let's say repo A depends on repo B version 1.1. And then the owner of repo B has the power to say version 1.1 is deprecated. And then repo A's build breaks. And it turned out this was the primary cause of dependency issues. So if you look at the graph that's on the screen, you see that thing that says validation error, and then there's another one that you can't read very easily that says wildcard version resolution error, but it's cut off. Those two basically both mean some form of dependency issue in our ecosystem. That basically means somebody has deprecated a dependency and that's breaking somebody else. And you can see that that dominates the cause of our green build failures. So the first thing we want to know is we want to know, okay, wow, so now we know what the problem is that we have to actually go fix. It's enormously huge. And, you know, and the way you do that, by the way, is you always, like, when you want to go through causes, the first thing you want to do is you want to figure out what you don't know or what is a mystery, right? And in this case, the first question that I asked is, what are the categorizations of errors? Because I just don't know that. And sometimes you feel like an idiot asking these questions and people look at you like you're an idiot. And then they go and they do the analysis and they're like, oh, wow, I learned something. Amazing. So, you know, that happens a lot to me. People look at me like I'm an idiot because I'm asking a question that sounds stupid. And then, you know, we do the data analysis and sometimes they still think I'm an idiot because there was nothing there. And then sometimes we learn something. So you just have to figure out. And so anytime I don't know anything, I just ask a question. I'm like, I don't know this. Can you go get me the answer to this? I think it might be a cause or a potential thing that we want to look into. And then you find that smoking gun like this thing. This is a smoking gun, right? Like, oh, it's all dependency issues. Okay. But there was a lot of other analysis that we did to get to that point. Now, we have a very large code base. Like I said, hundreds of millions of lines of code. We can't fix all of the builds all at once. So how are we going to prioritize, and how are we going to slice it? It's not just a technical issue that we can't fix them all at once, but large technical changes are always also cultural changes. And there's a rate limit that humans will accept change at. So it doesn't matter how fast you can send out PRs, that is not the rate limit. The lowest rate is how fast human beings can accept change without coming at you with pitchforks and torches, okay? So what's the most impactful way to go through this incrementally? And so I said, well, let's slice it by language. Let's look at the language slices, because we can tell that per repo. We have a system that classifies our repositories per language. And so here you can see that Scala and Java were the highest number of build failures. So this is not the number of total repos. This is just the number of repos whose builds were failing. However, in our offline ecosystem, it's much harder to fix the problem because it's harder to update dependencies, because that can possibly change the way that data in persisted tables changes. Like that can change data in persisted tables, and that's unsafe. Because you don't know like how you're going to affect some product very far away from you if you don't have complete like data lineage from the source table to the end table, right? And however, we also know that most of our primary online production services are written in Java. And that's the second largest category here. And so we figure, hey, let's do Java. And actually, we didn't start with all Java. We actually limited it down to what we just called active Java deployables, which were basically every Java deployable binary that had been deployed in the last 3 months and all of their transitive dependencies. So only those were the ones that we cared that we were going to fix. And then what we did was we actually then incrementally moved out from there. So we moved from active Java deployables, which we spent about a quarter on, to all Java. And then eventually we took on Python. We started with just the online Python deployables, and then we're going to expand to all Python. And then we expand out this way, basically. And I will note that with this expansion pattern, there was no general backlash. There was no huge problem. It all just kind of rolled out pretty smoothly. And nobody complained about how much work we were giving them or anything. And then, before dashboard, one of the first things you want to do is you just want to come up with one report one time to see if the data is interesting or useful, and if you're getting it in the format that makes sense. So the first thing we did was we just started to produce like a report that we actually produced manually by just writing SQL queries and just dumped it in a Google Doc. And this is the table at the top of that report, and then there's tables below this in the report. And there's 3 metrics in there, and because we're moving all those 3 at the same time. Okay. And so then, as part of this, we also discovered that it's not just dependencies that are breaking. It's actually a small number of dependencies that are breaking most of the consumers. So you can see here the actual names of the libraries that we have internally that were breaking most of our consumers. This is not the fault of those library producers mostly. By the way, the reason it says producer is we use the term producer and consumer to refer to dependency relationships. A library is a producer, and something that consumes it is a consumer. It's just that they have a lot of consumers. Like those libraries are very broadly used. They have a ton of consumers. So what are we going to do about this problem? Well, we're going to do a few things about it. So now we need a dashboard, because now we have actually multiple different use cases where on a regular basis, people need to interact with the data as they are doing work or as they are managing the process. Actually, we made 3 different dashboards. We made one for us to use as a central team for our action that we were taking centrally. That dashboard I will show to you at the end. It's in the appendix if you want to see it. We made another dashboard for leaders to see trends over time and to understand that things were getting better or worse. And then there's another dashboard for our end users who are the owners of these code repositories, the people who have broken builds. So the first thing we want to do before we farm out a bunch of work to everybody, because the first thing, you could just say like, hey, everybody go fix your stuff. You all go fix your stuff, go do manual work. Well, that's sure to garner you a lot of bad reputation. People are not going to be very happy with you. You just show up and be like, do work. One of the reasons they're not going to be happy with you is that had we done that, it would have been impossible. And the reason we know that is we looked at the data. And the data said, if these people try to fix their builds today, they will break again tomorrow, basically. And we will just make them churn over and over and over unless we centrally start doing some work first to fix it. Also, they often come to us and are like, we don't know how to fix this because it's something weird about the development ecosystem that is confusing to us. So we need to fix that ourselves centrally. So the first thing we did was we just went around to a bunch of those producers who were breaking the most consumers and said, did you really need to deprecate those versions? And surprise, most of them actually said no. Like, most of them had gotten into a process, a habit over time, where they just said, hey, we deprecate versions. That's what we do. Like they get old enough and then we deprecate them. And that breaks other people, and then I guess those other people have to do work. Whatever, they're not us. I mean, I'm being a little mean. That's not what they said, but people don't think about that. One of the principles of a development ecosystem is the pain needs to be on the people who create the pain, because if people can create pain that they don't feel, that pain just expands and expands and expands. And that's just a factor of human existence. So that's not like a bad quality of any of our library owners who are mostly actually very diligent and care a lot about the quality of their work. However, despite our work here, this is the graph of green builds percentage over time. And you can see that when we do these undeprecations in September, we sort of, things get better, and then they get worse again in October. And it turns out more people deprecated more stuff. And they, different people deprecated more stuff and broke a lot more people. Some libraries have a lot of consumers. They broke more people. So we said, guess what? You can't do that anymore. So this was actually one of the first times that we as a developer productivity organization changed from a gentle recommender of tools to a setter of policy. Because it had to be done. Like, to be clear, this thing about these builds, it affects our developers in real ways. Like, they check out code repositories and they're just broken. Or if you're a library owner and you're trying to push a change across many different repositories and check if it, like, if you're trying to upgrade your library and other people's code and you don't know if their build is passing or failing because it was already broken, this is a huge problem, constant problem. So we said, you can deprecate things, but all it means is you don't get any, that version can have no more new consumers, but nobody's build breaks anymore. You don't get to create unfunded mandates for your consumers anymore. The only case in which you do get to create unfunded mandates is if there's like a production breaking emergency, and then you can break everybody's build. That's fine. Like they can't build a thing that will break production if pushed. That's understandable. However, we didn't just like announce this to the company. We wrote it up, we got buy-in from our management, and then we, with the help of our management, shopped it around with a bunch of key engineering leaders. Not just the VPs and the CTO, but also some of the more senior engineers whose people really valued their opinion to be sure that everybody would be on the same page, and then when we got pushback, there was somewhere to go to. And we piloted it first. We tried it out with just a few libraries, and we said, you don't get to deprecate anymore. Is that okay? Let's see how that goes for a few days or a week. And then once we had rolled this out, the ecosystem was stable, we weren't getting continual breakages, then we went back and we did that first process again where we got people to undeprecate their versions, and now the graph just went up and up and up consistently over time. Eventually, we ran out of work we could do centrally. And at this point, there needed to be some way to actually manage people doing all this manual work. And so we created a system that we call the Code Health Policy Engine. And what it does is it says, if your build is broken, we've filed a ticket against you. You have 7 days to resolve it. And if it's not resolved in 7 days, we will escalate that up the management chain. And this only works because we had already solved ownership. So we knew who owned every repository. Okay? And if that manager, and if it still doesn't get resolved in the next 7 days, it will escalate again, and it up and up and up and up and up until it hits a VP. Okay? And that worked shockingly well. Like, way better than I expected it to. I thought, you're going to file tickets against people, they're going to ignore them, they got a lot of work to do. Man, that worked like gangbusters. We had an over 90% ticket resolution rate on filing. It was wild. What you see here is the view in our IDP that teams get to see the build breakages for their team. So I picked a fairly high-level team, fairly high up in the org chart, so that you could just get a list of some very, very old ones here. But it says that, and it links to the ticket, it links to the error, it tries to create, this is for our end users. This tries to help them take action. And this is an actual ticket that we filed against a funnily named, probably testing repository. But it says, it like gives them a specific example of what's happening. Here's the action. Here's the here's what you should do. And we also created a doc site that says, here's the policy, here's why it is, and here's a Slack channel, specific Slack channel for this effort that you can come to and ask us questions about, where we get a lot of questions. A lot of people come into that Slack channel, which is one of the reasons why we have all those docs, so that we can point people at the docs that say, because the very first thing you need with this is the policy. Has it been blessed by my VP? Yes, it has been blessed by your VP, or whoever the leader is in their space. Why are we doing this? It explains why we're doing this. How do I resolve it? It explains how to resolve it in most cases, but sometimes people still need help. They show up and they need help. And the other most common question is we said, hey, the ownership system says this repository belongs to me, but it doesn't. So we eventually added a section that says, is this not your repository? And it's actually in the ticket directly. It's not in the docs because it was such a common question. This all worked shockingly well. We went from a very low number to, as of recently, 95% of all of our repositories are building. As I said earlier, there was no major pushback. And because we stopped the bleeding with setting the policy, and then created a system that would sort of incrementally drive change in the data, the number steadily climbs on its own. If we did nothing, I believe this number would continue to rise to probably about 98%. There's a churn in the background that we still need to deal with. And this was not even the metric that had the most impressive gain. So we did the same process that I was describing to you here with the other four metrics, the ownership metric, which we resolved fairly quickly, the dependency staleness, and deployment freshness. And some of those numbers had even more impressive gains, but the story is too complicated to tell in a half-an-hour talk. And this has real outcomes. It's much easier to apply automated code changes, and because the automation can now determine if it is actually breaking you or not. And the same thing for our library owners. So at LinkedIn, one of the things that happens is when you submit a change to a library, if you claim that this is a minor version bump, it runs the tests of all of your consumers to be sure that you didn't break them. Because the definition of minor version bump is supposed to be is backwards compatible, right? And so all those tests are supposed to pass. And before, this was a minefield of pain for library owners because you could guarantee that a lot of the failures were invalid before. And now, only a very small percentage of the failures are invalid, which is a huge change in the quality of life and the productivity of our library owner. And that's it. That's my LinkedIn. That is my email address. And that is a link at the bottom to the Developer Productivity and Happiness Framework. I have a few minutes for questions.
I love the idea of passing it on up until someone, VP, gets hit with responsibility. I think that's very simple and brilliant. How did you track the ownership? That's something we're facing, and and keep things fresh, I guess, because there's the temporal element too of, person comes on board, person owns thing, person hits the lotto and leaves.
Yeah. So LinkedIn has a system that I'm not the tech lead of, but I can kind of talk about, called Crews. And the way Crews works is it has groups that represent teams that are synced with Workday. And Crews has a set of algorithms to ensure that there is always some human being who works at LinkedIn that owns every asset. And so it takes changes in Workday every day in batches, and then it makes decisions through a set of algorithms as to whether this is a team that is moving to a new manager or whether this is just a person who's moving somewhere else. And then it merges or changes asset ownership. And the guarantee of Cruise is that assets are always owned.
Okay.
Yeah.
And this was in-house?
It's in-house. We built it. But it's in our IDP. Like the UI is our IDP, and it actually was probably the most killer application of our IDP so far. Yeah.
Thank you.
Hello?
Hello.
How do you, so you made all these improvements, life is better, but how do you measure baseline and demonstrate the value return?
So at some point, you have to take it axiomatically. So at some point, you know there's a problem, and you are like, hey, this is a problem. We all agree this is a problem, and this is the problem we need to fix. I mean, if you really wanted to care about the outcome in this case, you would probably care about the success rate of certain types of migrations or automation tools that we run. That's what I would look at. There's other confounding factors in the way of that, which is that there's certain improvements that need to be made to those automation tools. So you have to sort of understand this is necessary. Like, this is a thing that has to be done. I mean, you can prove that logically. This has to be done in order for the other thing to be done. And as long as everybody agrees that this has to be done, that metric itself is the outcome. But are there other outcome metrics you could measure? Yes. Are there confounding factors in some of those metrics that would make it hard to prove that this is the cause of any change in that metric? Also, yes. But do you need to do that to know that you did the right thing always? No.
Hi. So awesome job, and we're kind of beginning our journey there, getting metrics put together and stuff. And we're at the stage where we're putting together that central data set. Does that Cruise app that feeds data, like you're saying, that goes into Workday, right?
It comes from Workday.
It comes from Workday.
Yeah, so data comes from Workday, and then that tells us what the team structure is. You can also create what we call virtual crews that don't map into Workday, that have, and also the rules of crews are they all have a manager of record. They must have a manager of record. And there's a hierarchy that shows them just like the teams. They get named. They also have a lot of other things. They have on-calls. As long as they, like, we also enforce a policy that every crew that owns production assets has to have on-calls. There's lots of other things that have grown out of it, but its first application was repository ownership.
And does that data get sent to other systems?
Yeah.
Okay.
So Cruise is the system of record.
Okay.
Yeah.
Thank you. Hopefully a quick question. Dependency management and how essentially the library owner would keep track of all of the client dependencies.
So the system, the good part of our system is that it does that. So there is a system we have called the dependency backend that you can actually query, and it will tell you the transitive consumers and the transitive dependencies of your repository. And there's a configuration file that says, here's all the dependencies of your system. Kind of like a lock file, basically.
Is it in-house?
It's in-house. Yeah.
That was if there was a vulnerability in a previous version. What's the process that you have? Like if there was a bug in a previous version of the library.
So if there's just a bug, then all you get to do is you get to say no new consumers, and then the library owner is required to run a migration. If the library owner wants that change to occur in the consumers, which they should because they should be responsible for the production impact of their system, then they have to run a migration of all of their consumers. And we provide them a tool. If it's just a version bump, that's a relatively straightforward tool to run. If it requires code transformations, that's harder. And if there's a bug that would like break production or cause significant production impact, then you do still get to break the builds of your consumers. But the only people who can approve that are now the dependency engineering team. So a team inside of the developer platform team has to approve all deprecations that could actually break production. Yeah. All right, thanks.